Hello everyone, welcome to my program. Today we will be solving another daily Leetcode program, and the problem's name is send zeros in row and column. So the problem statement goes like this. You are given a zero indexed integer array m of m cross n size. Basically it is a binary matrix, not an integer array. Okay, so then from this given array of m cross n size, which is binary matrix, the matrix is constructed whose name is difference, which following procedure to be uh, which is created by the following procedure. Okay, so let the number of ones in the ith row be ones row. Let the number of ones in the jth column be ones column. Let the number of zeros in the ith row be zero row. Let the number of zeros in the jth column be zero column. Okay, so then every entry in this matrix, difference matrix, or will be at coordinates I and j, will be given by this formula. Number of ones in row minus number of zeros in row. Number of columns, number of ones in a column minus number of zeros in a column. Okay, so you have to return this difference matrix. It's a pretty simple and straightforward question. And if you ask about the constraints, so the constraints are like this. Size of the matrix will be of order 10 raised to power 5, and breadth basically. Okay, and it is mentioned that it will be a binary matrix. So that's the problem and the constraints. Now let's see how we will be solving this problem. So it is to be noted this constraint is a special constraint here, because even if you go on traversing the matrix, let's say this constraint was not mentioned, and these three and this final one was the only constraints given, then what would have happened that even for traversing the matrix, even for you would have required order of n into m complexity, and it would have been 10 raised to power 5 into 10 raised to power 5, 10 raised to power 10. Okay, so this would have been these number of operations would have been required, would have been greater than the limit of the operations, which is 10 raised to power 8 operations allowed in 1 second. Would have got a TLE here. even just for traversing the array. So those of you who are not familiar with this operations limit, basically if the number of operations that your program is requiring uh, exceeds or become equal to 10 raised to power 8 operations, then you may get a TLE. So those of you who are new to this concept, I will be providing a link of an article describing how the time complexity of accepted solution varies according to size. Okay, so this constraint here, we are able to traverse the array in order of 10 raised to power 5. Note this. So its order is given here, order of 10 raised to power 5. Okay, so that's why we will not be getting a TLE. Now let's see the approach. Basically, the approach is pretty straightforward. What we will do is we will, let's say this is the matrix given to you. I think this would be appropriate example to take. Okay. Now let's say this is the input matrix. Now what is the sum of the, basically we will be calculating two sums. One will be the row sum, which will be sum of numbers in a row, and another will be one structure that we will be using will be row sum, another data structure which will be array, or also like this row sum will be column sum. Okay, sum of numbers in a column. Since it's mentioned here that your matrix is a binary matrix, so we can leverage that fact, and this will be equal to number of ones in a row, and similarly this will be equal to number of ones in a column. Okay, and number of zeros can be easily found out with this. If you know number of ones and number of ones in column and rows both, so let's say you have number of rows equal to rows, number of rows, and columns equal to number of columns. Okay, then it can be easily found out. What you have to do is simply subtract for the number of ones in a row, number of zeros in a row, it will be number of columns, which is false, minus number of ones in a row. Okay, number of ones in a row. What was the equation that was given to you for the calculation of each entry in this difference matrix? it was this. So let's say, let's take another slide. Okay, this equation was given to you. Now if we rearrange it a little bit, what we will do, we will replace this thing with minus 1's row I and I don't know why this is not working here. Yeah, it's fine now. And this thing we can replace with rows minus 1's whole j. Okay. Fine now. And then we can further rearrange it. It will be this thing twice of ones and column row, row and one's column, and minus columns plus rows. Okay. This is a more simplified version, and this is how we will be calculating each entry. So as you can see, the problems boils down to finding these two matrices, row sum and column sum, these two. Okay, so let's see how we will be implementing this approach. Let me quickly zoom out. Yeah, it's fine now. So row sum and column sum will be the two matrices which will be having dimensions of number of rows and number of columns, obviously. And this will be the difference matrix that you will be required to return. Okay, and row sum and column sum matrices. Okay, and once we are done with calculating these two matrices, we can simply apply that formula that we have just now formed here. We will apply this equation to get each entry in this difference matrix, and then at last we will return it. Okay, so this is how we will be solving this particular problem. It should have been an easy problem. It's not a medium problem actually. Anyhow, this is how we will be solving it. And if you are still having any queries or doubts in general, then please feel free to ask them in the comment section. Thank you for watching. Have a great day ahead.